12(2) goes over rational square roots. With these rational square roots, we're actually going to be able to simplify all of these square roots. You're not going to have a radical left over. If we look at example 1, for A, we just have the square root of 225. If you don't know off the top of your head that the square root of 225 is 15, you can see that it is divisible by 5 since it ends in a 5. And you can divide the number by 5. You get 45. 45 is 5 and 9. The 9 is 3 and 3. When we're doing square roots, we have that invisible index that's understood to be a 2. So you're grouping up sets of 2. Each set of 2, you're going to pull one of those numbers out. So we're just going to have 5 times 3, which is 15. For example B, we have the square root of 169. 169 is 13 times 13. Again, we're dealing with the square root, so our invisible understood index is 2. So we need 2 of the same number in order to pull one of those out. So the square root of 169 is just 13. For example C, we have the square root of 2,304. So this one, we see that it's an even number. So I'm just going to divide it by 2 to start with. So 2 goes into 2 one time, 2 goes into 3 one time with 1 left over, 2 goes into 10 5 times, 2 goes into 4 twice. This is also an even number, so 2 is going to go into it evenly. 2 goes into 11 5 times with 1 left over, 2 goes into 15 7 times with 1 left over, 2 goes into 12 6 times. From there, again, it's an even number, so if you want to divide it by 2 again, you can do that. If you want to try to divide it, let's say, by 4, you could do that also. If you divided it by 4, 4 goes into 5 one time with 1 left over, 4 goes into 17 4 times with 1 left over, 4 goes into 16 4 times. So that 4 is 2 times 2. The 144 we know is 12 times 12. If you do not want to break down that 12, you don't have to, because you do have a pair of it and our index is 2. So we're looking for groups of 2 of the same number. So each group of 2 that we have, we're going to pull one of those numbers out. We have 2 2s that are a pair, we pull one of those out. We have another set of 2 2s that are a pair, so we pull one of those out. We have a set of 12s that are a pair, so we pull one of those out. So we're going to multiply these. 2 times 2 is 4, times 12 is 48. So the square root of 2,304 is 48. For example D, we have the square root of 256. Again, if you didn't know off the top of your head what goes into 256 evenly, you can start by dividing it by 2 since it's an even number. We're going to do 4 for this one because 4 goes into 25 6 times with 1 left over, and 4 goes into 16 4 times. That 64 is 8 times 8. 8 is 4 and 2. The other 8 is 2 and 4. And that 4 is 2 and 2. If I broke down all the rest of these 4s, these 2's pair up, these 2's pair up, these pair up, and these pair up. So we have 1, 2, 3, 4 that pair up. We're going to multiply all those together. 2 times 2 is 4, times 2 is 8, times 2 is 16. So the square root of 256 is 16. For our next part of our lesson, we're working with fractions under these radicals. When you have decimals under the radicals, you can actually turn them into fractions and work with the fraction underneath the square root. When you're doing these, you're going to take the square root of the numerator over the square root of the denominator. So for example A, we have the square root of 36 over 121. So this one is just the square root of 36 over the square root of 121. From here, we're just going to have 6 over 11. And then for B, we have the square root of 49 over 81. So again, this is just the square root of 49 over the square root of 81. The square root of 49 is 7. The square root of 81 is 9. So it's just 7/9. Look at some examples. For example C, we have the square root of 121 over 225. This is the same exact thing as taking the square root of 121 over the square root of 225. We know that the square root of 121 is 11, and the square root of 225 is 15. We found that from one of the questions that we did on the other slide here, so we know that 11 over 15 is what we get when we find the square root of 121 over 225. For example D, we have the square root of 144 over 3025. So this is the same exact thing as saying take the square root of 144 over the square root of 325. When we do this, that square root of 144 is 12. And the square root of 3025 is 55. So this is just 12 over 55. Next, we're going to be looking at when we have these decimals under the radicals. So again, we said that if there is a decimal underneath that radical, turn it into a fraction. If you look at example A, we have the square root of 0.25. The 5 is in the hundredths place. So this becomes the square root of 25 over 100. So again, we're doing the square root of 25 over the square root of 100. The square root of 25 is 5. The square root of 100 is 10. And this simplifies to be 1/2. If you wanted to start from the very beginning by simplifying that 25 over 100, you would have the square root of 1 over 4, which is the same thing as the square root of 1 over the square root of 4. The square root of 1 is 1, the square root of 4 is 2, so again, you're still getting that 1/2. For example B, we have the square root of 0.16. That 6, again, is in the hundredths place. So this is the square root of 16 over the square root of 100. All right, so the square root of 16 is 4. The square root of 100 is 10. So then this simplifies to be 2/5. For example C, we have the square root of 0.0169. The 9 here is in the 10,000th place. So this is going to be 169 over 10,000 underneath that radical. So we're going to be taking the square root of 169 over the square root of 10,000. The square root of 169 is 13, and the square root of that 10,000 is 100. So we just have 13 over 100 for our answer. For our last example, we have 0.04 underneath that square root. So we're going to be taking that 4. It is in a thousandths place value. So we're doing 4 over 1,000, and that is under the square root. This is the same thing as saying take the square root of 4 over the square root of 1,000. That square root of 4 is 2. However, the square root of 1,000, that's 10 times 100. 100 is 10 times 10. So those 10s pair up. The 10 would come out. You still have the square root of 10 left over. You have to rationalize this denominator. You cannot keep a radical in the denominator. When you have a radical in the denominator and you are to rationalize it, you are going to look at the index. If it doesn't have an index, it's understood that it's a 2. You are going to multiply that radical by itself the amount of times that your index is. whatever you multiply to the bottom of that fraction has to be multiplied to the top of the fraction as well. So in this case, our index is 2, which means we need a total of 2 times that this square root of 10 is multiplied by itself. So you're going to multiply one more to the bottom. You'll do the same to the top. If you wanted to also simplify that 2 and that 10, you can. It would just be 1 and 5. So this becomes the square root of 10 over 5 times the square root of 100. The square root of 100 is 10. So that's the square root of 10 over 5 times 10, which is the square root of 10 over 15.